Welcome to the lecture series of Mechanics of Solids. In this lecture, we are going to solve more example based on center of gravity of composite volumes. So let us start with the problem. So this is the problem given. We'll read the data first. Find the CG of the system shown in figure. So here different objects are there. At the base, a cuboid is there which is having dimension 8 cm by 8 cm by 5 cm, on which a cylinder of 6 cm diameter and 8 cm height is kept, above which a cone having 6 cm height and 6 cm base is kept. So let us try to solve the problem following the predefined steps. First step is to identify any axis of symmetry is there or not. So by closely observation of figure, we can see one axis parallel to YY can be obtained about which this system is symmetric. So let us mark it in the figure. So this axis is axis of symmetry which is parallel to YY. So X bar can be directly obtained. So let us work out X bar first. X bar is equal to total dimension of body along X axis divided by 2. So this is the base of cuboid which is 8 cm wide. So X bar will be, so X bar has been obtained. Now second step, to decide the axis of reference. So let us mark axis of reference. So these are the axis of reference XX and YY. This axis has been selected such a way that this object remain in first quadrant. Now the third step is to fix this composite object into simple object. So this cone, that is object number 1, cylinder, that is object number 2, and cuboid, we can say it is object number 3. Now let us mark centroid of all this object. This is the centroid of cuboid. Here this is the centroid of cylinder, and we can say this is the centroid of cone. All these three centroid are lying on our axis of symmetry. So X bar has been obtained. Now Y bar is to be calculated. So to get Y bar, let us write the equation of Y bar first. So this is the equation through which we can work out Y bar. For that, V1, V2, V3 and Y1, Y2, Y3 are to be worked out. So let us start with V1. V1, that is volume of the first object, that is cone. We know the equation of volume of cone. So the equation of volume of cone, that is pi r square h by 3. Let us equate all the values. So by equating value of r, that is 3 cm, and h, that is height of cone 6 cm, the volume of cone has been obtained as 56.55 cm cube. Now let us work out V2. The second object is cylinder, and we know the volume of cylinder, that is pi r square h. So V2, that is equal to 226.19 cm cube. The value of r, that is 3, and height h has been equated. Now let us work out V3, that is volume of cuboid. The equation of volume of cuboid, that is L into B into H. So let us equate all the values. So equating the value of length, width and height, the volume of cone has been obtained as 320 cm cube. Now let us work out Y1, Y2, Y3. Y1 is the distance of centroid of cone, that is first object from reference x-axis. So it is the distance from this point to this axis. So this height is known to us, it is 5 centimeter. Height of cylinder is also known to us, that is 8 centimeter. We know that the distance of centroid of cone from the base, that is height by 4, h by 4. So 5 centimeter plus 8 centimeter plus h by 4 will give the value of y1. So let us write it. Height of cone is 6. So 6 divided by 4, h by 4 plus 8 plus 5. So the value of y1 has been obtained as 14.5 centimeter. Now let us work out y2. y2, that is distance of second object from reference x-axis. So this distance is known to us, it is 5, and this is half of height of cylinder, that is 8 by 2. So we can calculate it as, so this height is 5 centimeter and this is half of 8. So it will be So y2 has been obtained as 9 centimeter. Now y3, that is distance of centroid of third object along y-axis. So that is this much distance. It is half of the height of cuboid. So it will be 5 by 2. So it is 2.5 centimeters. Now let us equate all this value in equation so that we can work out y bar. So y bar has been calculated as 6.06 centimeter. Now let us mark the centroid in the figure. So this is the centroid of the figure, which is 4 centimeter from reference y-axis and 6.06 centimeter from reference x-axis. This way you can solve such problems. So this is a similar problem. A cylinder having 16 centimeter diameter and 20 centimeter height supports a cone having 16 centimeter base diameter and 20 centimeter height. Calculate CG of this system. So you solve this problem, write your answer in the comment box, and if you find any problem, face any difficulty, please write in the comment box. I will be there to help you. Thank you for watching this video. Thank you.